All right, so on the last lesson, we learned about arithmetic sequences, and there are sequences where something is added each time the common difference is added each time. Geometric sequence is a totally different type of sequence. So what do you think is happening with a geometric sequence? Multiply. Something is multiplied each time. And that thing that you're multiplying by is called the common ratio. And sometimes it's also called constant proportional change. You'll see that wording on multiple choice questions, so don't get too confused that multiplying by something each time the common ratio is the same as saying there is a constant proportional change. All right, and then just like the arithmetic sequences, there's two different ways we can write the rule. This way, you use an initial value. And R is the common ratio. And it is a lot less useful than the other equation, which you can use any term. And so A is for arithmetic, G is for geometric. So G sub K is going to be the kth term. Now using that one does make multiple choice questions a little more challenging because you have to figure out which term they used. Sometimes it's obvious, sometimes it's not, so you just have to be careful. But in general, it is definitely the more useful equation. All right, and geometric sequences behave like exponential functions, which we haven't talked about, but we will starting tomorrow. But you've learned about exponential equations before, or functions. The difference is they are not continuous. So when you graph a sequence, it's just dots. You don't ever connect the dots. All right, so let's do a sequence. We're going to graph this G sub n. So I'm just going to do a little table of values. Instead of x and y, we're going to do n and g sub n. And we actually can fit values from 0 to 4. Now don't forget that the domain of sequences are the whole numbers. You don't ever put in fractions, decimals, or negatives into a sequence. Okay, so when we plug in 0, what is 1/2 to the 0? Not 0. 1. Everything except 0 raised to the 0 power is 1. So then it's 1 times 8. All right, and then we put in 1 is 8 times 1/2. We put in 2, it's 8 times 1/4. 8 times 1/8. And then 8 times 1/16. And then if you just looked at the terms, you can tell that each time you're multiplying by 1/2. And it makes sense because 1/2 was the common ratio. The common ratio is whatever is being raised to the power. Okay, so let's graph this. We technically could keep going, but that fraction is just going to get smaller and smaller and smaller every time you multiply by 1/2. Is it ever going to get to 0? No, if you keep multiplying by 1/2, you're never ever going to get to 0. So that's it. All right. Then the next example, we are going to determine if the sequence is geometric. So on your assignment, it says to determine if the sequence is arithmetic, geometric, or neither. But for our notes, we're just going to decide if it's geometric. So when it's in equation form, what I do is I just look back at the equation for a geometric sequence. Does it look like either one of those? Does A look like either one of those? No. So it's just going to be no. All right, what about B? Definitely looks like the second one. What would R be? Yep. So whatever is being raised to the n power, that is going to be R. Okay, and then C, when we have a list of terms, we need to take one and divide by the previous one and make sure, or if it is geometric, you would get the same thing every time. Now, I can look at C and no, that's not going to happen, but we could test it a couple of terms. We would take 3 and divide it by 1, and then we would take 2 and divide it by 3. Obviously, that's not happening. It's kind of a weird sequence. It just takes 2 previous terms and multiplies by 2. Oh, it's weird. It's okay. All right, and then I told you that arithmetic sequences, positives and negatives, cannot alternate, but they can on geometric. So we would take -8 and divide by 16. And then we would take 4 and divide by -8. And just keep doing that, taking one and dividing by the previous one. And we do get a common ratio, or that's constant proportional change. All right. Let's look at number 7, or example 7. So G sub n is going to be a geometric sequence with G sub 1, or the first term, is 12, R is 2. We're going to start off and just write an expression for G sub n. All right, so since we're not given an initial value, I personally would just go ahead and go straight to this guy, where G sub n is going to be whatever we get for that first term, which is 12. Times your common ratio, raised to the n. And then what should I subtract from the n for this term? 1. All right, and then from there, I'm going to find the fourth term by plugging 4 in for n. And again, I want you to try and do as much as possible in your head. Now, if it's ever asking you like to find 2 to the 8th power, the AP people, hey Krish, the AP people are probably not going to want you to do that in your head. But 2 to the 3rd, yeah, I think they expect you to know how to do 2 to the 3rd in your head. So what do you guys think? What's 2 to the 3rd? 8. And then I also think that they would expect you to be able to multiply 8 by 12. If you can't do it in your head, it's okay. You just go over and do the old-fashioned multiplication. So the fourth term is going to be 12. Going to be 96. Okay, and then I have a sequence, and we're going to write a formula for G sub n. So I want you guys to pick any of those points and write a formula for G sub n, and I'll write down all the ones that are possible. Now, I'm not going to do the super small fractions, by the way. So when you're figuring out R, take one term and divide it by the previous term. And you can use any of these. So check your G sub n with one of mine. You do not have to write them all. This did end up being the same one we graphed back at the top of the page. That's fine. All right, and then what are we going to do to find G sub 10? plug 10 in for n. You can use any of these. I'm gonna use this one. If you're gonna do it in your head, I would say that would be probably the best one to do. I did not do this in my head though, because 2 to the 7th I don't have memorized. I did know 2 to the 5th is 32, and then you could multiply that by 4, and that is 128. But again, I don't think they're gonna want you to do that without a calculator, but I can't tell you for sure. It's doable. It is a little time consuming. All right, so I want you guys to try 9 and 10 on your own. So just have a reminder of the stuff that's on the other side of the page. In this case, it'll be a little different in a second. Bless you. Try to do 10 without picking up a calculator. Just see if you can do it. Bless you. All right, so don't forget, when you're cubing something, a fraction, you just cube the numerator and cube the denominator. And then what is 24 times 180? Yep, and that's it. The hunter asked a good question when he was doing this one about how do you know if this sub 3 is going to be n or if it's going to be k. And for a problem like this one, n has to be your variable. And so if you know the r and you know one of the terms, then this is definitely going to be k. Now, on the one we're about to do, that kind of gets thrown out the window. So sometimes you don't have consecutive terms. You have 2 terms, but there's some space in between them. In that case, sometimes this is n when you're setting it up, and sometimes this is k. So you have to be careful. I think what makes this easier to do when you're just given 2 terms is you use the larger k as n. So the larger term number is going to be the n value, okay? So when we go to do example 11, we're going to write the equation for g sub n. The larger k value is 6, so g sub n in this case is going to be 128. Let me write down the formula where I can see it. You guys don't have to rewrite it because you can just look up at your page. Okay, so 128 is the g sub n term. Negative 2 is going to be the g sub k term. R is what we're going to be looking for. And then what order do I subtract the 6 and the 3?
6 minus 3.
Yeah. So if you ever choose, like if, for example, if we had chosen negative 2 to be over here, that order would be in a way that you would get a negative value, and it's going to make it a lot harder for you to do. So we're going to do it this way, and it's going to work out nicely. Okay, so when I subtract 6 minus 3, I'm going to get 3. So I'm not sure if we've solved equations like this year, but I know you have in your lifetime. So what would we do now? Yes. That is something you could do in your head. All right. Now what would I do to just get R? Cube root. Right, and the cube root of 64 is something that I do want you to know. Do you guys know what it is? Yeah. And since it's negative 64, R is going to be negative 4. I'm using up a lot of space here. All right, so we still haven't done the first thing they asked us to do, is write an expression for g sub n. So we can use either term. We can use the 6th, or we can use the 3rd. Do you guys have a preference? Okay, so then it's going to be negative 2 times negative 4 raised to the n minus 3. All right, so that's the first thing we're supposed to do. Just took a while. And then the second thing, we need to plug 11 in for n. I don't think that this is something they would expect you to do without a calculator. It would be super annoying if they did. I don't think they would. So they don't expect you to know what negative 4 to the 8th is, or the 9th, the 8th. All right, so I'm going to plug that into the calculator. And that's going to be negative 131,072. So those geometric sequences get large very quickly at an exponential rate, actually. And then sometimes, like if your R is a fraction, they get really, really small quickly. Okay, we are going to do one more like that, and then you're definitely going to have time, or probably going to have time to get finished in class. All right, so here we go. We have to set this up using this formula right here. So what is the first thing we need to write on the left by itself? 1.5. And so the larger term number is 7, so it would be the 1.5 equals 48. R is what we need to find, and it should be raised to the 7 minus 2. All right, now I personally do not like decimals. I know a lot of people don't like fractions. I don't like decimals, so if I'm trying to do this in my head, I would change that to 3 halves. And then to get rid of the 48, I would multiply by the reciprocal of it. Now, I think this one is doable without a calculator personally, but I'm not sure. So I would know that 3 would reduce that 48 down to 16. And then when I multiply across the numerator and denominator, I get 1 over 32, which is nice, because when I take the 5th root, I know the fifth root of 32 is just 2. Okay. And then I want to write my equation. Because I don't like decimals, I wouldn't use the 1.5 because I just don't, they're terrible. I would use the 48. It might make it harder in the long run, but that's what I would do. Okay, then I would put in 11. All right, yeah, they probably would have you do this in the calculator, actually. If I gave you this one, I wouldn't have it be all the way to the 11th term. I would probably like have you find the second term or the 4th term or something like that. Okay, so what questions do you guys have? Okay, some people in my last class thought this was easier than the previous lesson.